Hey guys, welcome back once again today. So we will continue with the trees interview questions. Okay. So currently, if you are new here, we are solving DSA questions live, and we are following Kunal Kushwaha's DSA and interview preparation bootcamp, and we are trying to solve the problem ourselves first, and if we cannot do it, then we are seeing the video of Kunal to do that. So previously we were solving this question. Okay, so previously I will just switch. So previously we were doing this question, the binary tree zigzag level order traversal, where traversal, the question which was asked by these companies, all big tech companies. Okay, and the way we did the problem is we traversed the entire tree level by level, and while we got completed traversing to this level, okay, we just reversed the list. Why did we do that? Because the question asked us to do, because the question asks us to traverse in a zigzag pattern. Like we have to first we have to traverse like this, then we have to go like this, like a snake we have to traverse. Okay, so when the level is 1, we are going from left to right. When the level is 2, we are going from right to left. When the level is 3, we are going from left to right once again. So you can see the pattern. When the when level is even, we are going from left to right. When the level is odd, we are going from right to left. Alright, so this is roughly the concept, the idea behind the problem. Okay, so now we will try to solve it within O of n time. Okay, we haven't watched Kunal's video yet. We have solved it using our own logic. As you can see, that if the root is none, that means there is no node in the tree. So that time we are returning an empty list, and if not, then we are taking an answer. You can see over here the answer is a nested list which has the list inside a list. Okay, which has many lists inside of it of variable size. So initially it is empty. Okay, and we have taken a queue, a FIFO queue, first in first out queue. Okay, initially it has a content of root, the level count is 0 initially. Okay, and while the queue is not empty, we will keep traversing in this while loop, and we will keep performing. So what operations we are performing? First, we are saying that the number of iterations we need to do, the number of time we need to traverse in each level. Like this level has 4 items, so number of times we have to traverse is 1, 2, 3, 4. You see, like that. So each level has 1, 2, 3, 4 items. Okay, and the number of time we have to traverse will be equals to the length of the queue, because at each instance, at each level, the queue length will be equals to the number of items present in that level. Okay, if you don't understand, you just see Kunal's this video. You can follow Kunal Kushwaha's data structures and interview preparation bootcamp. Okay, here he has taught binary trees from scratch. As you can see here, 3 hours video. AVL trees, a beautiful concept, and segment trees. I understand the requirement of segment tree, but AVL trees I got fascinated much more. So this is the course that I'm following. Here Kunal is coding in Java, but because I'm more familiar with Python, or I'm trying to get more familiar with Python. I'm coding in Python language, as you can see. Okay, so we are applying this logic, and as you can see, when the level is even, then we are reversing it, as you can see in our logic over here. And this is completely fine, as you can the worst case time complexity will be O of log n, which is good enough for lead code. But what if the company asks us to do it in O of n time? Then I don't know how to do that. So in that case, I have to see Kunal's video to see if there are any more possibilities, any more algorithms, with the help of which I can solve this problem in O of n time, not O of log n time. To be honest, O of n and O of log n does not make quite a big difference if the input is not huge, because you're multiplying a small number with because when you take log of a number, the number is already quite small compared to the original number itself. Okay, so let us see how he solves it.
Check it out, Forkit, and just all the links can be found in the description. You can check it out once. Okay, next question. It says binary tree zigzag level ordered reversal. This question has been asked in Google, Amazon, and Microsoft. It's a joke. You can see 10,000 thumbs up. This question is nothing. This is a very easy question. Copy paste, literally, just a little bit different. Okay, the question is simple. You have to print it zigzag manner. So it says level ordered reversal. So you know breadth first search will be used. But how do we print it in zigzag order? Let's see. Let's say you're given a tree. You're given normal tree. Okay, something like this. You have to print it in zigzag order. Means first you have to print 1. Print 1. Why is it not changing my color? Okay, print 1. Then print it like this. Then like this. Then like this. So answer should be 1,
2, 1, 3, 2,
3, 2, 4, 5, 6, 7, 11, 10, 9, 8. Not a problem. I can do that. And here you can see that every alternate. So what you have to do is think about what is happening. We know breadth first search will be used. One more pointer I would like to give you is when you know a certain algorithm is being used. Like I know here breadth first search will be used. Try to solve it using breadth first search and see how you can modify it. I will try solving using breadth first search. So in my queue I will have 1, and I will be like, okay, I will just print 1, add in 2 and 3. Not a problem. Now what I have to do is I have to print this whatever I have level now left in the array in the queue. You know, whenever level is finished, I will have next level left in the queue. We know that. So level 1 finished. Now I have another level left in the queue. I know that this level I have to print in reverse order. I have to print this level in reverse order. So instead of removing from the front of the queue, I have to remove from the back of the queue. So let's say I can remove from the back of the queue. Then I will just remove 3. Where will I add 6 and 7? Again, remember that if I add 6 and 7 in the behind, then I cannot remove 2 because I am removing items from the behind. So I will just add 6 and 7 in the front. See, now if I add 6 and 7, then I cannot remove 2 because then it will remove 7. I will add 6 and 7 here. Then I will remove 2 will be printed, and I will add 4 and 5 here. Now I'm in the regular order again, so I will remove 4 normally, 4 printed, I will add 8 and 9, so on and so forth. 5 removed, I will add nothing. 6 removed, I will add 10 and 11. 7 removed, I will add nothing. Now again I have to print. Now again I'm in the reverse order. So in the reverse order what I'm doing is I'm removing from the very simple problem solved. So normal order, what you have to do is remove from front, add in back. Reverse order, remove back, add in front. Simple. See how came remove behind, remove queue, left in the array in the queue. You know, whenever level is finished, I will have next level left in the queue. We know that. So level 1 finished. Now I have another level left in the queue. I know that this level I have to print in reverse order. I have to print this level in reverse order. So instead of removing from the front of the queue, I have to remove from the back of the queue. So let's say I can remove from the back of the queue. Then I will just remove 3. Where will I add 6 and 7? Again, remember that if I add 6 and 7 in the behind, then I cannot remove 2 because I am removing items from behind. So I will just add 6 and 7 in the front. See, now if I add 6 and 7, then I cannot remove 2 because then it will remove 7. I will add 6 and 7 here, then I will remove 2 will be printed, and I will add 4 and 5 here. Now I'm in the regular order again, so I will remove 4 normally, 4 printed, 4, 7. So I will add 6 and 7 here, then I will remove 2 will be printed, and I will add 4 and 5 here. Now I'm in the regular order again, so I will remove 4 normally, 4 printed, I will add 8 and 9. See, now if I add 6 and 7, then I cannot remove 2, because where will I add 6 and 7? Again, remember that if I add 6 and 7 in the behind, then I cannot remove 2, because I'm removing items from the behind, so I will just add 6 and 7 in the front. See, now if I add 6 and 7, then I cannot remove 2, because then it will remove 7. I will add 6 and 7 here, then I will remove 2, 2 will be printed, and I will add 4 and 5 here. Now I'm in the regular order again, so I will remove 4 normally, 4 printed, I will add 8 and 9, so on and so forth. 5 removed, I will add nothing. 6 removed, I will add 10 and 11. 7 removed, I will add nothing. Now again I have to print. Now again I'm in the reverse order. So in the reverse order what I'm doing is I'm removing from the left. Very simple, problem solved. So normal order, what you have to do is remove from front, add in back. Reverse order, remove back, add in front. Simple. You see how I came to this approach. I started using breadth first search, then I sort of like just modified it by doing what the question is asking me to do. I explained to you my thought process also. I can do this using DEC or DQ in Java. DEC or DQ, it's pronounced DEC, but you can call it DQ also, whatever you like. In that, Q is first in, first out. In DEC, you can add in and remove from either of the sides. Simple, that's it. So in constant time, so from the front or the back, you can remove, not a problem. That's it. And I can just maintain a pointer, not a pointer, a flag that when I'm in reverse order. So reverse for this will be equal to true, then reverse will be equal to false. This way I know when I need to start adding from the back. Then again, reverse will be equal to true. Initially, reverse will be equal to false. Okay, try code.
Deck is coming again and again in every question. You see, the question we have solved before as well. How I'm implementing the stacks and queues here is by using normal list. You can see over here, right? So in normal list, we can delete the front item with the help of q.pop and the 0th index. Okay, and this is not quite efficient internally. So the majority of the people who are submitting it, as you can see, solutions, then majority of people who are submitting it, who has 100% or close to, yeah, you can say 100% time beats 100% of the people, right? That they are using DEC because it is more time efficient and also space efficient to do that. So I don't know how to implement DEC. So I believe it is a good time to learn DEC. So let us learn about how to implement DEC in Python. UE in Python. Oh. Which video should we see? Yes, I don't want. Yes, I also don't want. Should we see this video? Harry explains quite good. I guess we can.
गाइस आज के इस वीडियो में हम लोग देखने वाले हैं डबल एंडेड क्यू, जिसको DEQ भी बोला जाता है। एक बात यहाँ पर आप लोगों को बताना चाहता हूँ कि जो डबल एंडेड क्यू है उसमें मैंने कैपिटल D कैपिटल E क्यू लिखा है, यानी कि डबल एंडेड क्यू। इसको आप अपने DQ वाले जो हमारा क्यू का ऑपरेशन था DQ, उससे कंफ्यूज मत करना, ठीक है? तो मैं यहाँ पर लिख देता हूँ नॉट टू बी कंफ्यूज विद DQ, नॉट टू बी कंफ्यूज्ड विद DQ, ठीक है? NQDQ वाला DQ है, उससे आप कंफ्यूज मत करना इसको। इसके फुल फॉर्म है डबल एंडेड क्यू। और इसका मतलब क्या है, डबल एंडेड क्यू क्या होती है, ठीक है? मान लो कि आप क्यू को एरे से इंप्लीमेंट कर रहे हैं और यहाँ पर बहुत सारे लोग हैं जो कि यहाँ पर स्टोर में खड़े हुए हैं, कुछ भी खरीदने के लिए खड़े हो सकते हैं, भिंडी की सब्जी हो या फिर बैगन की सब्जी हो, ये सब लोग खड़े हुए हैं, इनको अपने घरों में जाकर सब्जी बनानी है और ये एक जैसे दिख रहे हैं तो लेकिन अलग अलग हैं, ठीक है? सो अब हम लोग यहाँ पर क्या करेंगे कि इसको यहाँ पर मार्क कर लेते हैं फ्रंट ए और ये रेयर है, ठीक है? ध्यान से सुनना, बात को एकदम कहानी की तरह सुनाऊंगा और ऐसा बताऊंगा कि आप लोग जाके नहीं भूल पाओगे, ठीक है? और मान लो हमने इसको एरे की सहायता से इंप्लीमेंट किया है, हमने क्यू की इंप्लीमेंटेशन देखी थी, हमने मान लो इसको एरे की सहायता से इंप्लीमेंट किया हुआ है। तो एरे की इंडेक्स की बात करूं तो ये -1 होगी इंडेक्स, जहां पर मेरा एरो लगा हुआ है इसको मैं यहाँ पर -1 लिख देता हूं, ठीक है? ये 0 होगी, ये 1 होगी, ये 2 3 4 5 6 और अगर इसमें जगह है तो 7 8 9 10 भी होगा, ठीक है? मान लेते हैं इसमें और जगह है तो 7 भी मान लेते हैं, ठीक है? मान लो इसमें और लोग आ सकते हैं, ये रूट का अंदर नहीं है, सिर्फ क्यू की बाउंड्री है, ऐसा मान लेते हैं, रूट की बाउंड्री नहीं है और यहाँ पर 7 8 तक और एलिमेंट्स आ सकते हैं। अब हमारे पास जब इंसर्शन की बात आती है तब हम क्या करते थे, हम कहते थे कि रेयर को आगे बढ़ा दो, यानी कि 6 से 7 पे ले आओ रेयर को, और यहाँ पर जो भी व्यक्ति है उसको खड़ा कर दो यहाँ पर इस तरह से, ठीक है? जो भी इंसान है वो यहाँ पर खड़ा हो जाए। तो मैंने यहाँ पर क्या किया, मैंने रेयर को एक कदम आगे बढ़ा दिया, यानी कि मैं अब अपने रेयर को 7 पे देखना चाहता हूँ। 7 पे क्यों देखना चाहता हूँ, क्योंकि मैंने वहाँ पर एक एलिमेंट इंसर्ट किया है, रेयर पे मैंने एक एलिमेंट इंसर्ट किया है। तो मैं यहाँ पर क्या करूँगा, इसको रेयर लिख दूंगा, ठीक है? ये मेरा रेयर हो गया। तो फ्रंट मेरा यहाँ पर था, रेयर मेरा यहाँ पर आ गया और यहाँ पर एक और इंसान मैंने खड़ा कर दिया, ठीक है? तो वो भी क्यू उसने ज्वाइन कर ली। अब डबल एंडेड क्यू में क्या होता है कि डबल एंडेड क्यू में हमने क्या देखा था, इसमें क्या प्रिंसिपल फॉलो होता था, फीफो होता था या लीफो होता था? जो फर्स्ट इन होता था वो फर्स्ट आउट होता था, तो हम फीफो प्रिंसिपल यहाँ पर यूज करते थे क्यू में, ठीक है? DEQ में ये यूज नहीं होगा, ठीक है, फीफो यूज नहीं होगा डीईक्यू में। क्यों नहीं होगा देखते जाओ। डीईक्यू का मतलब होता है डबल एंडेड क्यू। तो जो आपकी क्यू होती थी, मैं आपको जिस तरह से लिखता हूं, जो हमारी क्यू होती थी, जो कि हमने देखी है, उसमें हम क्या करते थे, मैं आपको कुछ ऐसे लिखता हूं कि जो इंसर्शन होता था, इंसर्शन हमारा फ्रंट से होता था, तो मैं यहाँ पर लिख देता हूं इंसर्शन, सॉरी इंसर्शन रेयर से होता था, इंसर्शन फ्रॉम रेयर, और डिलीशन कहां से होता था, डिलीशन फ्रॉम फ्रंट, ठीक है। तो हम लोग यहाँ पर क्या करते थे, जो हमारा इंसर्शन होता है, यानी कि कोई भी इंसान आएगा तो वो अगला 8 पे आएगा और रेयर को हम आगे बढ़ा देते थे, जैसे मैंने आपको करके दिखाया, रेयर 6 पे था, रेयर को मैंने आगे बढ़ा दिया 7 पे, और यहाँ पर 7 को खड़ा कर दिया, ठीक है। तो इसी तरह से आपको डिलीशन करना है, तो क्या होगा कि ये इंसान जो है वो चला जाएगा, फ्रंट को हम आगे बढ़ा देंगे, स्टोर को आगे बढ़ा देंगे। तो फ्रंट इनिशियली -1 पे होती है, आपको रिमूव करना होता है एलिमेंट, आप उसको एक कदम बढ़ाते हैं और एलिमेंट रिमूव हो जाता है। ये चीज हम लोगों ने ऑलरेडी देख ली थी। हम फ्रंट को आगे बढ़ाकर एलिमेंट्स को डिलीट करते जा सकते हैं। तो फ्रंट को अगर मैं यहाँ पर आगे बढ़ाता हूँ और इसको डिलीट कर दूं, तो फ्रंट यहाँ पर आ जाएगा, यहाँ से हटा के, तो वो सारे काम में जो है वो कर सकता हूँ, ठीक है। डीईक्यू में क्या होता है ये देख लेते हैं। जो डीईक्यू होती है उसमें कहानी थोड़ी सी अलग होती है। आप इंसर्शन कर सकते हैं, इंसर्शन आप लोग कर सकते हैं फ्रॉम रेयर, और आप लोग फ्रंट से भी कर सकते हो इंसर्शन, जी हाँ, कोई भी घुस सकता है लाइन में। ये होती है डीईक्यू, डबल एंडेड क्यू। और जो डिलीशन है, बिल्कुल सही केस किया आपने, डिलीशन भी फ्रॉम रेयर प्लस फ्रंट, यानी कि दोनों जगह से आपका डिलीशन संभव है। इसका मतलब डबल एंडेड क्यू में क्या होता है कि सबसे पहले तो फीफो फॉलो नहीं होता है, ठीक है, फीफो फॉलो नहीं होता है, क्यू वैसे फीफो को फॉलो करती है, लेकिन यहाँ पर फर्स्ट इन फर्स्ट आउट वाली कहानी जो है वो फॉलो नहीं होती है। और उसी के साथ साथ इंसर्शन फ्रंट और रेयर दोनों से हो जाता है, डिलीशन भी फ्रंट और रेयर दोनों से हो जाता है, ठीक है। तो ये एक स्पेशल तरह की क्यू है जिसमें आपको डिलीशन और इंसर्शन सारे एंड से प्रदान किया जाता है। अब आपसे अगर कोई कहे कि यार फ्रंट से एक एलिमेंट डालो, तो फ्रंट से आप एलिमेंट भी डाल नहीं सकते। अच्छा, अभी आप लोग फ्रंट से एलिमेंट नहीं डाल सकते, लेकिन अगर मैं बात करूं इस इंसान को रिमूव करने की, यानी कि मैं फ्रंट को बढ़ा दूं यहाँ पर और इस इंसान को मैं रिमूव कर दूं, और फ्रंट को बढ़ा दूं वापस यहाँ पर और इस इंसान को रिमूव कर दूं, तब क्या होगा, क्या तब आप लोग फ्रंट से इंसर्ट कर सकते हो या नहीं कर सकते हो। मान लो कि ये एक इंसान आ गया जिसका नाम है अभिषेक, ठीक है, इसका नाम अभिषेक कर देते हैं। आपको इसको इंसर्ट कराना है आगे से, यानी कि फ्रंट से आपको इंसर्ट कराना है, तो आप क्या करोगे कि इसको यहाँ पर ले आओगे और इसको पीछे मूव कर दोगे। तो इसका कोड बहुत सिंपल होगा, आप लोग को इंडेक्स को एक कदम पहले इंडेक्स पर एलिमेंट को रख देना और फिर उसको एक कदम पीछे कर देना, यानी कि फ्रंट वाली इंडेक्स पर आपको उस इंसान को खड़ा कर देना, उस एलिमेंट को लगा देना है एरे के अंदर, और उसके बाद आप लोग को फ्रंट को डिक्रीमेंट कर देना है। तो इस तरह से आप फ्रंट से इंसर्ट कर सकते हो। तो इंसर्शन फ्रॉम फ्रंट इज प्रैक्टिकली पॉसिबल, अगर रिस्ट्रिक्शन नहीं है, अगर फीफो वाली बात आप लोगों को यहाँ पर फॉलो नहीं करनी है, आप डबल एंडेड क्यू इंप्लीमेंट कर रहे हो, तो आप इस तरह से फ्रंट से इंसर्शन कर सकते हो। अच्छा, हमने कहा था रेयर से जो है हम लोग इंसर्ट कर सकते हैं, रेयर से डिलीट कर सकते हैं। हाँ बिल्कुल कर सकते हैं, रेयर से डिलीट, और रेयर से डिलीट करना तो बहुत आसान है कि आप इस इंसान को जो है ऐसे एक कदम पीछे, आप लोगों को जो डीईक्यू पे बता दो, बस बिल्कुल बड़ी चीज नहीं है, बस हमने जो किया था वही कर रहे हैं। पहले हमने इंसर्शन फ्रॉम रेयर, डिलीशन फ्रॉम फ्रंट है, ठीक है। इसमें क्या अलाउड है क्या अलाउड नहीं है, तो क्या अलाउड नहीं है वो मैं आपको बताऊंगा, ठीक है। तो यहाँ पर जो रिस्ट्रिक्टेड इनपुट डीईक्यू है उसमें क्या नहीं आप कर सकते वो मैं आपको बताता हूँ। तो रिस्ट्रिक्टेड इनपुट या फिर इनपुट रिस्ट्रिक्टेड डीईक्यू जो होती है उसमें आप क्या नहीं कर सकते, आप यहाँ पर इंसर्शन फ्रॉम फ्रंट नहीं कर सकते, फ्रॉम फ्रंट इज नॉट अलाउड, ठीक है। इसके बाद रिस्ट्रिक्टेड आउटपुट डीईक्यू में क्या अलाउड नहीं होता है, डिलीशन फ्रॉम रेयर इज नॉट अलाउड, ठीक है। तो यहाँ पर हम लिख देते हैं डिलीशन फ्रॉम रेयर इज नॉट अलाउड, ठीक है। तो डिलीशन फ्रॉम रेयर अलाउड नहीं होता है, किसमें रिस्ट्रिक्टेड आउटपुट या आउटपुट रिस्ट्रिक्टेड डीईक्यू भी बोलते हैं इसको। तो रिस्ट्रिक्टेड आउटपुट डीईक्यू में कि आउटपुट जो है वो रिस्ट्रिक्टेड है, इसका मतलब क्या हुआ कि आप डिलीट नहीं कर सकते पीछे से। ऐसा नहीं कोई इंसान आया और उसको पहले सर्व कर दिया जाए पीछे से, नहीं, आगे जो होगा उसको सर्व किया जाएगा, लेकिन कोई आगे लग सकता है, ठीक है। तो ऐसा आप समझ लो, अगर जगह है तो आगे आके लग सकता है। तो ये है रिस्ट्रिक्टेड इनपुट रिस्ट्रिक्टेड आउटपुट डीईक्यू। अब आप लोग हो गया इसका कोड, इसकी इंप्लीमेंटेशन। तो इसकी कोड इंप्लीमेंटेशन लिखने के लिए मैं आप लोगों को एक काम करूंगा कि इसका एडीटी बना के दिखा दूंगा, और मैं इसका एडीटी एक बार आपको बना के दिखा दूंगा ना, तो आपको डेफिनेटली सब कुछ क्लियर हो जाएगा। मैं डीईक्यू एडीटी यहाँ पर आपको बताऊंगा। इसको कभी भी डीक्यू मत पढ़ना, इसको डीईक्यू पढ़ना, डबल एंडेड क्यू। तो यहाँ पर मैं आप लोगों को डीईक्यू एडीटी के वो मेथड्स बता दूंगा जो कि आप लोगों को इंप्लीमेंट करने हैं। तो जो डीईक्यू है मैं यहाँ पर लिख देता हूँ डीईक्यू, और डीईक्यू के साथ एडीटी भी लिख देता हूँ ताकि क्लियर हो जाए यार मैं किस बारे में यहाँ पर बात कर रहा हूँ। तो डीईक्यू एडीटी, ठीक है, डीईक्यू एडीटी मैंने यहाँ पर लिख दिया है। अब मैं यहाँ पर आप लोगों को ऑपरेशंस बताता हूँ। जो डेटा है वो तो सेम एज आपका जो हमने क्यू था वो है सेम एज क्यू। ऑपरेशंस के बारे में बात कर लेते हैं। ऑपरेशंस कौन कौन से हैं, ऑपरेशंस कौन कौन से आप इसमें करा सकते हो। तो देखो इज एम्प्टी, ये एम्प्टी है, क्यू है नहीं है, इज फुल, ये सारे ऑपरेशंस तो रहेंगे ही रहेंगे, ठीक है। और जो हमने बाकी ऑपरेशंस देखे थे क्यू के अंदर वो सारे तो रहेंगे ही रहेंगे। एनक्यू डीक्यू की जगह क्या आएगा आप ये देखो, एनक्यू डीक्यू की जगह आएगा एनक्यू फ्रंट, एनक्यू रेयर, ठीक है, एनक्यू फ्रंट, एनक्यू रेयर, और डीक्यू फ्रंट और डीक्यू रेयर, यानी कि पीछे से आपको अगर एलिमेंट को निकालना है तो डीक्यू, और इन क्यू में आप लोग को आगे से इंसर्ट करना है, पीछे से इंसर्ट करना है, जहां से भी क्यू में इंसर्ट करना है आप कर सकते हो इन चारों मेथड्स का इस्तेमाल करके, ठीक है। तो यहाँ पर मैं इसको ऐसे बना देता हूँ दिखाने के लिए, ये मेथड्स है, ठीक है। तो ये आपके 1 2 3 4 5 6 और ये ट्रिपल डॉट का मतलब ये वो सारे मेथड्स जिनके बारे में हमने पहले बात की थी, जैसे कि आप क्यू को अगर प्रिंट कराना चाहते हो या फिर आप अगर क्यू को इनिशियलाइज कराना चाहते हो तो वो सारे काम आप कर सकते हो। तो ये हमारा डीक्यू एडीटी है, ठीक है। तो मैं काम कर लेता हूँ यहाँ पर कि इसको इस तरह से ना लिखकर अगर मैं आप लोगों को ये मिटाकर जो ऑपरेशन है एक्जैक्टली उनको लिखाई दूँ, कंफ्यूजन थोड़ा सा कम हो जाएगा आप लोगों के लिए। तो मैं ये तो 3 डॉट मैंने लगाए हुए हैं, इनको मैं ऐसे करके लिख ही देता हूँ कि यार कौन से ऑपरेशन, एक तो इनिशियलाइज है और इनिशियलाइज के साथ साथ एक हमारे पास प्रिंट है, ठीक है, प्रिंट ऑपरेशन कि आप अगर क्यू को प्रिंट कराना चाहते हैं, सारे एलिमेंट्स देखना चाहते हैं, तो हमने देखे 1 2 3 4 5 6 7 8 ऑपरेशंस, ठीक है, 8 ऑपरेशंस हमने देख लिए। तो ये है हमारा डीक्यू एडीटी, ठीक है। इसको इंप्लीमेंट कैसे करेंगे, आप लोग को इसको खुद से इंप्लीमेंट करना है। तो मैं यहाँ पर लिख देता हूँ बड़ा इंप्लीमेंट योरसेल्फ, और बहुत आसान इंप्लीमेंट हो जाएगा, ऐसी बात नहीं होगा, और करोगे ना तो मजा आएगा। मैं बता रहा हूँ आपको, इंप्लीमेंट खुद से करना है इन सारे ऑपरेशंस को। देखो 4 ऑपरेशंस तो इंप्लीमेंट हो रखे हैं, आपने पुराने वीडियोस देखे हैं, पिछले वाले इससे पहले वाले वीडियोस में प्लेलिस्ट में वो देखे हैं, तो वही रखे हैं सारे के सारे, ये वाले ऑपरेशंस तो मैंने करा रखे हैं। इनक्यू एफ, इनक्यू आर, तो देखो इनक्यू आर मैंने करा रखा है, ठीक है। इनक्यू आर हमारा जो क्यू का नॉर्मल इनक्यू है वो है। डीक्यू एफ करा रखा है, डीक्यू एफ भी तो करा रखा है। कभी भी हम डीक्यू करते थे तो कहां से करते थे, हम लोग फ्रंट से तो डीक्यू करते थे। तो कभी भी हम निकाल रहे हैं एलिमेंट तो हम उसको रेयर से नहीं निकालते थे, हम उसको फ्रंट से निकालते थे, ठीक है। तो इसलिए डीक्यू एफ, इनक्यू आर, ये आपको बस इंप्लीमेंट कर लें, ठीक है। इस पर मैं टू डू का लेबल लगा देता हूँ, टू डू टू ठीक है। तो ये आपको करना है इम्प्लीमेंट। इन क्यू एफ बहुत आसान है, करके दिखाया मैंने कि भाई फ्रेंड्स अगर इन क्यू करना है तो सबसे पहले तो चेक करो कि ये जो -1 है ये -1 तो नहीं है। अगर ये -1 है इसका मतलब नहीं आ सकता, और अगर ये 0 है तो आप यहाँ पर एक इंसान को खड़ा करके इस पी क्यू सब, अगर आप सिस्टमैटिक वे में डेटा स्ट्रक्चर्स एंड एल्गोरिथम सीखना चाहते हो अभी के लिए इस वीडियो।
In today's lesson, we're going to be covering DEQ, which stands for double-ended queue. Why this is called DEQ, and inside there we insert our list. So now we've converted this list into a double-ended queue, and we're just going to be going over a lot of the methods that come with this double-ended queue and how we can actually use this to handle queues in any kind of system. Pretend you have a queue of people, for example, that want to ride a roller coaster. This is a perfect example on how you can use that to manage that queue. But the most common one you'll have in every list is the append method. So let's pretend Bowser wants to join the queue. Now when we go ahead and print this queue, you'll notice that we'll have a queue with Bowser at the end of the queue, and the type that we're going to get back is a DEQ, but this can be treated as a normal list. For example, if we go ahead and say, let's see what's happening in the queue at the index of 1, we'll get Luigi back, so it can be treated as a normal list. But now let's go ahead and pretend that Mario has left the queue. So let's go ahead and type in queue, and we're going to get a new method called popLeft. In a normal list, we can pop things, but it's only from... In a normal list, we can go ahead and pop elements, but that's usually only from the end of the array. So with this, we can go ahead and call popLeft, and when we go ahead and print the queue, we'll see that Mario has left the queue, and now Luigi is next in line. But now let's go ahead and say that Daisy decided to cut the line. So here we're going to go ahead and say append left, and this is another convenience method we get with queues. So here we can go ahead and say Daisy, and when we print the queue, we're going to get Daisy in front of everybody. Daisy decided, I don't want to wait, I have princess powers, I'm just going to go to the front of the line. Now let's go ahead and pretend that Daisy went on the ride, and then she decided, okay, I'm going to be fair this time, I'm going to go to the back of the queue and wait my turn again. So Luigi will be next again, even though Luigi never got his turn yet. So to create a rotation, all we have to do is go ahead and call rotate and insert the index of -1. So this will move everyone to the left 1. Otherwise, if you don't insert anything, everyone's going to move to the right 1. So we're going to start with -1 to demonstrate this. And let's go ahead and print the queue. So print queue. And Luigi will be at the front and Daisy will be at the end. And as I mentioned earlier, if you don't pass anything in, it's going to do it in a different way. So we're going to have Daisy going backwards while Bowser goes to the front of the queue. And that's not really a queue-like behavior, but that's... Otherwise, if you don't insert anything, everyone's going to move to the right 1. So we're going to start with -1 to demonstrate this. And let's go ahead and print the queue. So print the queue. And Luigi will be at the front and Daisy will be at the end. And as I mentioned earlier, if you don't pass anything in, it's going to do it. So print queue. And Luigi will be at the front and Daisy will be at the end. And as I mentioned earlier, if you don't pass anything in, it's going to do it in a different way. So we're going to have Daisy going backwards while Bowser goes to the front of the queue. And that's not really a queue-like behavior, but that's just how it is by default. And the great thing about this rotate method is that you can insert any number you want. So if 2 people went on the ride, we can go ahead and add -2. So Daisy and Luigi went together, and now they're at the back of the queue, while Toad and Bowser are now in the front of the queue. But we'll keep that at -1. Now let's pretend we want to append more than one person to the end of the queue because people are coming in loads. So one way to do this is to call the extend method. And just like everything, we have extend left and extend, which just goes to the back of the queue. So here you can pass in any array, Daisy going backwards while Bowser goes to the front of the queue. And that's not the index of -1. So this will move everyone to the left 1. Otherwise, if you don't insert anything, everyone's going to move to the right 1. So we're going to start with -1 to demonstrate this. And let's go ahead and print the queue. So print the queue. And Luigi will be at the front and Daisy will be at the end. And as I mentioned earlier, if you don't pass anything in, it's going to do it in a different way. So we're going to have Daisy going backwards while Bowser goes to the front of the queue. And that's not really a queue-like behavior, but that's just how it is by default. And the great thing about this rotate method is that you can insert any number you want. So if 2 people went on the ride, we can go ahead and add -2. So Daisy and Luigi went together, and now they're at the back of the queue, while Toad and Bowser are now in the front of the queue. But we'll keep that at -1. Now let's pretend we want to append more than one person to the end of the queue because people are coming in loads. So one way to do this is to call the extend method. And just like everything, we have extend left and extend, which just goes to the back of the queue. So here you can pass in any array, just as with extend left. And here we're going to go ahead and add Shy Guy and Yoshi. And now when we print the queue, instead of just appending one person, it's going to append both Shy Guy and Yoshi to the end. And if we do extend left instead, it's going to put them at the front of the array. And the final method I want to bring up here is the reverse method. And this one is quite common no matter where you are. All it does is reverse everything in the array. So Yoshi will be at the front and Luigi will be at the back, as opposed to what we had earlier. But at the end of the day, always make sure to use what you think is most convenient. I think using the deck instead of a list can make a lot more sense when you're working with any kind of queue, because even though you can create all of this in a normal list, deck just has so much more functionality right out of the box that doesn't confuse the programmer or require the programmer to create any unnecessary computation.
Alright, quite self-explanatory and easy to understand, I believe. So let us try.
this. Okay, so deck we'll be using, and you can Google it as well. Java deck or DQ. Here you can find. So in constant time. So from
Okay, quite easy to be honest. So what did we understand over here? Let us see. Yeah, let us see. So previously what we were doing, we were traversing in BFS order. We were traversing the array in BFS order, and whenever the level was 2, we were reversing it after each level traversal. Okay, but it is taking O of log n time, O of n log n time, है ना? So approach 1, I will write both the approaches over here. Do BFS traversal and at every even level reverse the level array, or in Python we say list. Okay, this is approach 1. This takes O of n log n time. So the better approach, approach 2, what we can do in approach 2, we will have a queue over here. Initially the queue will have 3. Let me write a bigger queue. Yeah, okay. Initially suppose we have 3. Okay, so in when level is 1, then insert from the back. Is it? Yeah, I guess so. Insert in the back. 3 will be here, cut over here, and what was that? What Harry taught? So 4, 2, 3. One, 3, 2. What do we want? We want 3, 29. So let me see it once more.
So when you know a button 2, I will have 1, and I will be like, okay, I will just print 1, add in 2 and 3. Not a problem. Now what I have to do is, I have to print this whatever I have level now left in the array, in the queue. You know, whenever level is finished, I will have next level left in the queue. We know that.
Okay. So when the level is finished, yeah, okay. So in approach 2, we can see that when we are in the odd level 1 we are in. Okay, so we have put 3 over here. We will print 3. Then we are pushing in 9 and 20 for that. Okay, this is the end of level 1. So the end of level 1 is here. Now what we need to do? Now we need to go from right towards left. Okay, so for now we have to print 20 from right towards left, and we have to pop the element children of 20. So if we pop them right of 20, then the problem that will occur is it will then print 15 and 7 first, so which we don't want. We want it to be printed. We want this level to be traversed later, so we will insert it over here. We will insert in the left 15. The left item will be 15 and 7. Okay, 15 and 7 inserted, and this level we are inserting the right subtree first, and then we are inserting the left subtree. Okay, yeah, this thing we have to also take a note of. So 20 is done, then we have to traverse 9. So print 9, then add the children of 9 into the queue. So for that we have to insert the right child first. So we are inserting the right child first, 99, and then we are inserting the left child, which is 69. So this is the way, and again we will follow it for the rest of the items. Okay, so what things do we need to note down over here? My room is a mess. No worries. Yeah. When level is 1, when level is odd, then from left to right we have to traverse, then left to right we have to traverse, we have to insert children at end, and then what we need to do, we have to insert children from left to right. Insert children from left to right when level is even. Then what we need to do, then we will go from right to left, insert children at the beginning, children's at beginning, and one more which is very important, that insert children from right to left. Okay, so these are the things that we need to keep a track of Alright, so let us implement that in code. First, have anyone left any chat over here? Guess not. So we shall continue. So the function definition that I can see over here is like this. Okay. I will open VS Code because I don't know the implementation of deck as of now. I will paste it over here. In place of tree node, I will replace node and optional I need to import, and I have to use deck to use this. So I have to say that if root is none, then return, what do we need to return? Return an empty list. Okay, so if root is not none, then we will take an answer list over here, which will be a nested list. We will also create a queue, will be equals to deck, which will get imported automatically, I guess, from bypassing is it the right deck or deck from collections? What deck do we need to use? Let me check in the Google. I have GPT turned off, so let me check it from the Google only. Deck from collection or bypass. Q.Q and collections of deck. So in deck the space complexity is 1, time complexity is so in queue, oh no, in deck it is there, it is the time complexity. Last GPT. Best in Python. Exit collections dot deck or something else. Okay, here's the font. Okay, collections.deck is the preferred choice. Q.Q is also there, but it's thread safe version of collections.deck. Alright. So it is fine. Collections.deck is fine, I guess. Yeah. So deck we have got. Now let us see what functions that we can get from here. We have append left. Here we get copy. We have a count and count the number of items, I guess. Extend is there. Extend left is there. Pop left is there. What does extend do? What does extend do? What does it do? It's okay, I understand. It expands the queue even more. It takes an iterable and it expands it more. I want to take it out. So I will print it. I want to check this tech functionality myself. So I have given an array as an initial input. So I will print Q. See what it gives us. I will comment these guys out, and it is giving us 1, 2, 3, 4, 5, 6, 7. I want Q dot append. Append will do, I know it will do append left. I know it will do. What will extend do? Extend will do 1, 2, 11, 12, 13, 14, 15. What will it do? I want to see. Print deck. No, print Q. Okay, it was right. It takes an iterable and extends it. Okay, nice. But why does it do it in reverse? In extend left, it is doing it in reverse. 11, 12, 13. Okay, this is interesting. It's doing it in reverse. Right? It's taking one element each and it is appending it in the front until it reaches the last element. Interesting. So what next? What do we have? Pop left, I know what it will do. Pop, I know what it will do. Remove an index, I guess. Clear, what will it do? It will clear out. Copy. Deck of int, why? What will it do? We'll copy it. We'll return a deck. Count. What does it do? Just say I'm giving 3. What will it return? Copy. Paste it over here. It is returning. Count 3 is 1. Why? Okay. The number of times 3 is occurring over here. That is what it is telling me, I guess. Yeah. Okay. Count 3. It was pretty self-explanatory. I'm the foolish one that did not understand by this. Reverse is quite explanatory as well. Index will return a sub. Index will return either one integer value or an object or an array itself. Okay, insert, I can insert in index. Maximum length, I don't know what it will do. maximum length it can has, I guess. Let's see what it is, what it does. Q.max length. Let us print it. Let us see what it does. It's saying none. Why? I don't know. Let us ask ChatGPT. What does it mean? Generate. Now, how to hide this? Okay. Okay. When we specify the max length equals to 3, then it won't allow us to have more than 3 items in that queue, reducing our time, reducing our effort to monitor that. It is quite helpful, to be honest. In recurring customers, when when you say that after a particular amount of time your subscription has expired, maybe it can help in that. Or in spite of giving rotating array or rotating list, this is much better in my opinion. Thanks. So when we insert 4, it automatically removes 1 from the front, because first in first out from normal queue principle, as you can see, as we know already. Okay, so we have 1 concurrent viewers. Hi, thanks for watching. So let us see now. I've understood what I needed to. Let us implement it in our method as well. Okay, so we have taken an object of deck for easier queue implementation, which is better than what I was doing previously, making a list and performing queue operations on the list, which is not very much efficient in terms of time and space complexity. Okay, so here, what do we need to do? Until the queue is empty, we need to traverse. Before that, we have to say level is even or odd. Is odd. Initially it is odd, will be true. Right? TRUE. Initially the level is odd because it starts from level 1 itself. Okay, so while queue is not empty, we can go, while queue is not empty, what do we need to do? We need a level list over here, which will store the levels from left to right. Okay, queue dot, do we have empty over here? No, we don't. There are special functions. No, we don't have a function called empty over here. So I guess it works like a normal list. I'd hope that it works like a normal list. Otherwise we have to do Q, length of Q every time. Okay, equals to 0. Let's have a fingers crossed. Let us see. So the level is 0 as of now. So the level is 1. The level is 1, so level is odd will be true. And for this odd level, the number of iterations that I need to do will be length of this Q. Alright, do we need anything else as of now? No, we don't. So we will start iterating for the scope in range. And what will we do? We will go from the level can be even or level can be odd. So if level is even, if level is odd is true, then we will do some certain operations, else we will do some other operations. Okay, so if the level is odd, then we have to traverse from left to right in the queue. Traverse from left to right in the queue. Then, so for that, sorry, I got shifted. So to do that, to traverse from left to right in the queue, what will we do? It will store the value here, like in the normal, like we do in the normal queue, right? Queue dot pop left. We are popping the left item and storing this in the node, right? So okay, we have stored this in the node. Now we have to check if node dot left is not none. We have to insert the children at the end from left to right. So we will check insert the children from left to right. Insert children at the end. Append the children's at the what the hell? Children, okay, sorry. Sorry for the grammar. Append the children at the end of the queue. Okay. Append the children. Children is plural, so we cannot use S over there. So append the children at the end of the queue from left to right. Queue left first, then right. Okay, so left first, then right we are appending. Alright, then what we need to do over here, then if the node dot left is not null, we will insert it. Okay, we'll insert it at the end of the queue. So append will work. QUE dot append right. Append will be node dot left. If node dot right is not none, then we will again append this into the queue. Alright, and then we will add the value into the list. We'll add the value into the list. Okay, node level dot append the item. Which item? Node dot value. Node dot value. What is this? Value, I guess. Taken value. Yeah. Node dot value. Value. Else, if the level is even, then we have to traverse from right to left. And then what we need to do while traversing right to left, we will pop from the right. Okay, node will be equals to 920 is traversed. Okay, then pop will be node dot pop QUE dot pop normally from the right. Okay, so now the first step is done. Traverse from left to right. We have popped the node. Then append the children at the beginning, at the left, at the start. Yeah, start sounds good to the ears. Append the children at the start. Right first, then left. Okay, append the children at the start, right first, then left. Okay, so because we have given right first, we will check the right node is not none, dot right not none, node dot q dot append left, appending in the front, node dot right. If node dot left is not none, then we will append q dot append left, node dot left. Okay, we are done over here. And after that, as usual, we are appending the current node. Are we doing correctly? It's popping 20 first, then it is popping 9, then it will, the end will be over, and 20 and 9 will be popped into the answer. Yeah, it is correct. So level dot append will be node dot value, because we want the value over here. So after this for loop terminates, actually, these two things are common for both of them. So shall we do it twice? Shall we do? It is easier to read, to do twice, so let us leave it there as it is. Okay. So I will go to the indentation of the for loop. So when the for loop is done, we are still inside the while loop, and we will append it, answer dot append into the answer list. Let us see what it will give us. I will create a binary tree, will pretty print it, and I will also do dot zigzag order, not zigzag level order. It takes the root value, so bt dot root is there. So let us see whether it works or not. It should work. It is returning none. Why? Okay. We have not returned anything. So after the while loop, yeah, we are there now. After the while loop, you have to return the answer itself. Sorry, my mistake. It is saying null. Why is it saying null? Why is it saying okay. I have to once the appending is done, I have to, when the one level is done, we have to alternately change it, right? So how can I alternately change? How can I make true false and false true? I can use if condition, or I can use binary. Let us ask GPT how to make true, false, and in Python without using if. Okay, we can use a not gate over here. So each level odd, after the completion of each level, we have to reverse it. Each level odd. Okay, now I guess it should work. Still not working. Why is it not working? If root is none, then return none. Okay, shall we debug it? Ideally, I shouldn't be debugging it like this, because I won't get this facility in the interviews. It is not an answer, it's a deck has been initialized. Okay. I got it now. So initially deck has nothing in there, so that is the problem. So we need to put root the initial value. It's not an iterable. Okay, so we will we'll encapsulate that. It is still not giving us a correct answer. It should give me 4, then 6, 2, then 1, 3, like that. 1, 2, 3, 4, 5, 6, 7. So it should give me 4, 6, 2, then 1, 3, 5, 7. It is not giving me that. So there must be a problem. 1 is giving, 6, 5 is giving. Why? 6, 5 is giving. Why? Let us check where we have done our mistake. Initially the queue has only one item. Okay, the queue is not empty. Yes, it is not empty. The level is initially null. The number of iterations will be 1. Okay, so the for loop will run exactly once. So the level is odd. Yes, it is odd. So it will go here. Node will be equals to q.popleft. Q.popleft will pop the first item, which is which is 4, and it will append the items children at the end of the queue. Will append the children at the end of the queue, left first and then right. So node.left is appended first and node.right is appended, and level, and after that when we do this, we are appending the value as node.value we have appended into the level. Okay, the 4 got appended over here. So now let us see what happens. So now the queue has 2 items in that, so the queue is not empty. The level is again initialized to an empty list. N will be equals to 2 now, so the for loop will run twice exactly. Level is odd. No, it is not odd, because after the for loop execution got ended. No, this is a problem, I guess. The for loop execution did not got ended and we changed it. It should be here, not over there. Yeah, Python indentation makes a huge difference, as you can see. One indentation ruined the entire code. After the for loop got ended, then I should reverse it. Reverse the boolean value. Otherwise I should not. Right. So I will copy it. I will copy the code that we have implemented here. I will paste it. Here. I will do, yeah, fine. Seems good. If there, return, we shall run it. It is giving us an attribute error. It does not have any attribute called value, because we have written value over there. So it should be val. Anywhere else I don't think so. I have made same problem, mistake. Yeah, it is running. 44 seconds. Let us submit. It should work as well. So Amazon, Facebook, Microsoft, Bloomberg, Google, Apple, LinkedIn, Oracle, Adobe, all of these companies have asked the question. You can see it is beating 87% of the people using Python 3, and in memory it is beating only 65.29%, but it is quite good. If you I would have done the previous method, like just reversing it. Where is it? Yeah, just reversing it. Yeah, level dot reverse whenever the count value is 2. I would have done that personally, because if it gets accepted, then why to bother that much? But this is the more efficient way. It is good to learn, and why not? So we have learned a lot of new things. Then there are pop left, pop right, pop left and normal pop, and append left and normal append, and other functions that deck offers us. Okay, I will write the note during the college classes. Okay, so let us move on to the next question, shall we?
So level 1 finished. Now I have another level left.
I guess this is done. I've understood how is it going. Let me see.
The queue. I know that this level I have to print in reverse order. I have to print this level in reverse order. So instead of removing queue, this approach. You can do this using deck, and you can here normal order means not reverse, and if reverse, okay, or I can just say else. And after that, I will also say after this thing, I have to switch it. So if reverse is false, next time it learns just flipping it. If it is okay, if it isn't okay, or I can be more specific, pole first, add it in the back. Okay, current node offer, right? Add it in the back. So I can just use add last also, just to make it clear to you. Otherwise what? Remove from back and add it in the front. Pole back, add first. That's it. Okay, one thing here, it will pole last, and also one more thing. When I'm adding, let's say in the reverse is true, I'm adding, I say I removed 3, so I was adding 6 and 7. If I'm adding from first, I will first add the right and then I will add the left. So for example, if let's say I removed 3, and here I need to add 6 and 7 in the first. So if I add left first, see what will happen. Left added first, see, write it down again. Say I remove 3, then I need to add 3 dot left, Google, Amazon and Microsoft. Nice, pretty easy. Let's move forward. Okay, now similarly now it's asking level order bottom. Also very simple question. It's saying given the root of the binary, you are doing level
Level order traversal, second one. 107. I guess we have done this already. 107, yeah, already done. Level order traversal. Here what we need to do, the return from the bottom level order traversal. Yeah, quite easy. Very easy, not quite easy.
order reversal, but print it in reverse order. 1870, and now nothing you have to do. You can specify index, very relatively new one that was asked. This question was asked in Amazon, very simple, last year, so 2022, Amazon London Software Development Role. This question is, you will laugh at this question. It's actually
populating the next pointers in each node. Let us try it ourselves first, then we will see Kunal's approach. This is lead code 116. Okay, so lead code 116 is there. Populating next pointers. So companies which have asked is Facebook, Bloomberg, Microsoft, Amazon, Walmart, Apple, and these companies. Google and Flipkart have, Adobe, Oracle have asked the question also. Quite a long back. So the star ones are asked recently, more recently, asked in the recent interviews. Okay. That's all. If you are given a perfect binary tree where all these are on same level, every parent has 2 children. A binary tree has the following definition: struct node, star left, right, and next. Okay. Populate each pointer populate each next pointer to point to its right next node. If there is no next node, then the next pointer should be pointed towards null. Initially, all next pointers are null. So here a perfect binary tree is given. Okay. So here it does not have anything because the level has only one item. So it should definitely point towards null for sure, for obvious reasons, you know. So these are pointing. 4 should be pointing towards 5. 5 should be pointing towards 6. 6 should be towards 7, and 7 towards null because nothing. The A got empty because the level got empty. Okay. So, is there any constraints? You may only use constant extra space. Recursive approach is fine. You may assume it is a stack space does not count as extra space for this problem. Okay. So we cannot use an extra space for here for our approach. But because we are doing BFS, best first search, we need a deck or queue to traverse in BFS order. So the number of nodes it can have can range from 0 to the power 12 minus 1. Oh my god, a lot of nodes it can have. Okay. So if the root is none, we can say it does not have anything, so return none. Return we need to return anything? No, it should return none, I guess. Yeah, output is this. Yeah, we don't need to return anything, I guess. The next pointer should be none. Okay, we are not returning anything. So yeah, okay. So if the root is none, then we are not returning. We are returning none. We are not doing anything. If it is not, then we will have to traverse in BFS order. Okay. To traverse in BFS order. So we have to traverse in BFS order in the tree. Alright. So now, what are the requirements to traverse in BFS in a tree? The requirements are: we will need a node. We will need a queue. Deck. We will initialize deck, I guess. DEQV, yeah. Deck. We will initialize to a queue. What else do we need? Initially it has a value of root node itself. Okay, and we don't need anything else in this case now. So while the queue is not empty, what do we need to do? We need to traverse level by level. Okay, so to traverse level by level, what can we do? So directly pointing towards its next item. So we don't need any extra level arrow over here. Okay, we don't need an extra list level over here. What is it doing? It is pointing towards the next node. It is just pointing towards the next node in the queue. Okay, so now what we need to do, we need to pop the node from the queue, queue object we have made, UE dot pop left, because we are using deck, and because we have popped left, the popping is done. Okay, so because we have popped the left item, we have to iterate for one item each. So n will be equals to length of q. So for dash in range n, then we will traverse. Okay, so for dash in range n, we can see that node will be equals to q dot pop left. So it is popped, the node is popped. Then what we need to do, then see here, a queue is there. What is the question number? Lead code 116. Lead code 116. The question number is there. So initially 1 was there in the queue. We have popped 1 and saved it in node. Okay, so now the queue is empty. So because the queue is empty, the level got finished. Okay, so now we have to point the next attribute, the next variable of this node, which is node.next, that if queue is not empty, then is there a peak option? I guess not. Let me do one thing. Can I print QV and the 0th index? Can I do that? I don't know. 0th index, yeah, I can do that. I can access the 0th index like this. If queue is not empty, I can just say that node dot next will be equals to QUV of 0th index. Otherwise, the node is empty anyway. So I will try to comment that if the queue is not empty, point towards its next node in the level. In the for loop, we are traversing in each level by THROUGH through this for loop. Alright, so deck is done. It's pointing towards the next node. If cube is not, then initially it is already pointing towards none, so no need to change that. So after that we will have to insert it. Insert the children normally, which is if node dot left is not none, we will have to say qvv dot append node dot left. Otherwise, if node dot right is not none, we have to append qvv dot append node dot right. Okay, this is the logic. We don't need to return anything, I guess, because we are not asked to. Q dot append dot right. Yeah, I guess this should be enough. Let us check. Pop left is not there. You mean pop? Yeah, I meant pop left. Yeah, obviously I meant pop left. Why wouldn't I mean pop left? She's giving me a wrong answer. The output is none. It is none. But why? Why the output is none? Is it asking me to return something? Is it asking me to return something? Then why hasn't it mentioned over here? You fools. While after the while is done, then return the root node itself. Yeah. Is that what you want? No, it is not what you want. It is not what you want. Then what you want? Root is not what you want. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Why is it doing it once again? Why? Q dot next is pointing towards Q, right? Q should be, we are popping Q. We are popping node 1 from here, okay? 1 is popped. 1 is popped from here. Then when 1 is popped, the node will be equals to 1, and if Q is not empty, the node dot next will point towards A, but here Q is empty. Q will become empty because we have popped, so it will be still pointing towards none. Okay, so 1 is pointing towards none, so our output is also pointing towards none. Okay, so now if Q is empty, if Q is not empty, node dot left, Q dot append node dot left, Q dot append node dot left. Yeah, Q dot append 2 is appended, then 3 is appended. Okay, so this has come to level 2. So in level 2 we have popped 2 will be node, and 2 will become node, there's some silly mistake. 1 2 3 dash 4 5 6 7 hash 4 5 6 7 hash. Why is it printing twice? So node is 2 will be node. Node.next will be pointing towards 3. Okay, yes. And then the children of 2 will be put here. Say 4 and 5. Okay. Then it will again go for 3. 3 will be pointing towards 4. It should not be pointing towards 4. Yeah, that is the problem. Okay, now I understood why it is not working. So now I understand why it is not working. So we have to take one index I in the for loop. Okay, so we have put q over here. If I is less than n, I guess, so because when the second iteration is less than n minus 1, because if the number of iteration is 2, then only one is pointing. The number of iterations is 4, 1 2 3 4, 1 2 3 4, then only which is 1 2 3 4, and only 3 will be pointing towards this next. So it should be 0 0 1 2 only when 4. Okay, 0 1 2 only. So this should run. Yeah, let's submit this. Let us see if it has passed all the test cases. Yeah, it has passed all the test cases. It has beaten 96.97% of all the people in terms of runtime. Memory, it has beaten 71.71%. Good enough. It was asked by these questions, these companies. Quite easy. Yeah. I wonder how much time they give for these kind of questions. Do you have any idea? Okay, our stream got copyright claimed, but no problem. So what can we do now? On to the next question. This was quite easy. Populating binary tree, binary right side view, presence in the binary tree, symmetric tree, TFS. I think this is enough for today. I shall go and yeah. So I guess this is enough for today. I shall go. So a video on machine learning is coming really soon. I will be posting reels consistently regarding machine learning, deep level machine learning, not top level, where we will deep dive into the math of how to optimize machine learning codes with the help of matrix multiplication and linear algebra. Okay, super cool stuff that the tech giants are using. So I like that a lot, so I want to share that. And I guess people don't have much attention span to retain through all the duration of the video, so Reels is a better option nowadays, I guess. So if you like this video, give this video a like, and let me know how I can improve and what kind of videos you want to see next. So that's all for now. See you in the next video. I will be back with Flutter live stream very soon, probably 1 hour from now. So let's see how it goes, or I can come at night as well. I don't really know, so let's see how it goes. Bye bye, see you, have a good day.